Now we talk about polarization. So for an individual wave, the direction of polarization is defined as the direction in which the electric field is vibrating. So we have seen this figure before in electromagnetic wave chapter. So you have the propagation direction and you have electric field and magnetic field. So electric field here is given in red. So you can see the direction of polarization is in the direction of electric field. So this is the direction of polarization of this individual wave. But the waves are emitted by big wave sources. For example, the sun is a big wave source. It is emitting all kind of rays. So these rays then superimpose on each other, and therefore what you get is a mix of waves. So when you get a wave on earth, it is basically a mix of large number of waves, and therefore you get all possible directions for the vibrating electric field. So say there is a wave which is traveling out of the screen. So direction of propagation is out of the screen, and you know that the electric field is perpendicular. So this is the wave which is probably coming from the sun. So it has electric field in all these directions. So electric field is in all these directions because large number of waves have superimposed upon each other to form this wave. So such a wave is called unpolarized light beam. So this is an unpolarized light beam. So a wave is linearly polarized if the resultant electric field vibrates in the same direction all the time. So for example, you just have one of these arrows. So this is the linearly polarized because now here the electric field is vibrating in the same plane all the time. So this is unpolarized. You have electric field in all directions, and this one is polarized. You have electric field vibrating only in one direction. So you notice that in this diagram, this is a polarized wave, obviously because it's just a single wave. So electric field is vibrating in this red direction. Sometimes it is up here, sometimes it is down here, up here, down here, up here. So in one direction it is vibrating. Now we talk about Polaroids. Now the Polaroids basically polarize the light which pass through it. By polarizing, it means that they will just keep one direction for the electric field. So they are going to linearly polarize unpolarized light beam. So how does it work? So it polarizes the light passing through it by selective absorption. So it absorbs all other fields and just lets one direction of electric field pass through it. So Polaroid is generally made up of long chain of hydrocarbons, and it's a very thin sheet, and all of them are aligned in a particular direction. So the molecules, these hydrocarbons, will absorb light whose electric field is parallel to their length and allow light through whose electric field is perpendicular to their length. So suppose the hydrocarbons are aligned in this direction. So this dotted arrow. So this direction is called transmission axis. It's called transmission axis. So the story is you have this unpolarized beam of light. So this is unpolarized. It falls on the polarizer. Once it falls on the polarizer, then only one direction comes out. The direction which comes out is the one which is aligned with the transmission axis. So only this E0 comes out. All others are absorbed. So now see, this is polarized. So this now is polarized. So this works by selective absorption. So anything which goes through the transmission axis will come out as such. So more technically, you can say that the molecule will absorb light whose electric field is parallel and allow light whose electric field is perpendicular. But rather than getting into the technicalities, we just worry about the transmission axis of the Polaroid. So only the electric field which is in the direction of the transmission axis will go through. Now you can, this is say polarizer 1. Now you can put another polarizer behind this polarizer 1. Now this E0 is going through. This is E0. This is falling on the second polarizer. Now this dotted ray is again its transmission or the optic axis. So this is again the transmission axis, or you can say the optic axis. So now you can decompose this E0 vector into E0 sine theta and E0 cos theta. So this cos theta component is going to pass through because it is along the transmission axis. So what you get here is E0 cos theta, and you could have your camera here or any other instrument which has these polaroids in front of it. So this second polaroid is often called the analyzer. So we are saying that a second polarizer called analyzer can also be put in the path of the polarized light. So the component allowed to pass through the second polarizer is given as E cos theta. So these polarizers are, what are they used for? They are used for sunglasses, cameras, window panes, etc. So large number of cameras, in fact almost all the cameras use polarizers because they help in getting the right kind of picture quality.